The sun has begun its red giant phase, expanding like an overheated plasma-filled balloon. It's about to consume Mercury and then epically engulf Venus and eventually swallow Earth. Even now it's broiling our planet to bone-scorching temperatures. This is Earth 5 billion years from now. But how did we get here? Well, let's take a journey through time from this very moment you're watching this video, all the way to that day, 5 billion years in the future, when the sun is far bigger, brighter, and way too close for comfort. It's about to get hot, radioactive, supervolcanic, and deadly. The next H100 red years of your life is going to be one of the most unpredictable centuries in human history. The impact of tech, AI, climate change, medicine, and renewables are going to be nearly immeasurable. But if you're thinking about what things are going to be like in billions of years, well, you gotta think bigger than just your own backyard. Mostly because every backyard on Earth is eventually going to be incinerated. We have to think galactic. In just the next decade, humans will send probes to far-flung planets and moons like Venus and Europa. We'll send people to explore the South Pole of our own moon. And it'll be the first time this century that anyone set foot on our closest cosmic neighbor. Within 50 years, you might be watching the world go by from a lunar moon base or even exploring the surface of Mars. Within a couple of hundred years, you, thousands of settlers, and whatever robotic pets you want to bring along with you will be living on Mars permanently. Back on Earth, humans will be working to get the planet's average temperature back down to a manageable number, while you will set out to terraform the red planet. Your goal is to bring a greenhouse effect to Mars to warm the place up. In the darkest corner of our solar system, things would be getting a little heated. Pluto would cross Neptune's orbit and become closer to the Sun than the ice giant. But don't worry, this happens every couple hundred years and only for some 20 years at a time. And speaking of the outskirts of the solar system, humanity will finally discover local extraterrestrial life, if it exists. The moons of Enceladus, Europa, Titan, and Triton all have potential for life in their ice-capped oceans. This life could be microbial or feature wildly advanced multicellular body designs. The next time Pluto swaps orbital spots with Neptune just shy of the year 2475, humanity and our robotic overlords will finally finish terraforming Mars. Or underlords, we'll see. But that's right. Finally, planetary scientists, chemists, engineers, biologists, basically every kind of scientist that's ever existed, used barely comprehensible technology to solve the unsolvable problems of living on Mars. Like overcoming the lack of heat, atmosphere, oxygen, water, a magnetosphere. Together we created a red planet where human, transhuman, and cyborg relatives can walk freely on a remarkably Earth-like surface. Your backyard could include a view of a pale blue dot, whether your backyard is on Earth or on Mars. After that, we'll start settling every other available rock in the solar system, including asteroids and the massive moons of the gas giants. You'll move to Venus to build cloud cities and commute in helium-based zeppelins. Now would be the time to start terraforming Venus. First we move there, then we terraform. Now these projects take a long time, but fortunately the human lifespan has increased radically. Medicine of the 26th century makes the most advanced treatments of today look like leeches and bone saws. By the year 2500, you will live longer than ever, comfortably reaching 150 years of age on average. And in your old age, you'll be golfing on Mars and clogging up tech hotlines. On a larger scale, humanity has reached a long-standing theoretical milestone. We've finally become a Kardashev Type 1 civilization. The Kardashev scale was created by famed astrophysicist Nikolai Kardashev as a way to envision a civilization's technological prowess based on its energy consumption. A Kardashev Type 1 civilization is capable of harnessing and using all the energy roughly equivalent to what our Earth can potentially provide. That means you, if you're living on Earth, have figured out how to use every bit of wind, tide, solar, biological, geothermal, chemical, fossil, and nuclear energy on the planet. Wherever you and your brainy pals see a source of energy on Earth, well, you've already figured out a way to use it. And if you need more energy, you're gonna need to go further afield. Within a couple of hundred more years, say by the year 2700 or 2900s, you've actually terraformed Venus. Feels weird to me to say the 2900s. Like just the other day I was saying the 1900s. Is it just me? Yeah, it's just me. To turn a planet like Venus into something resembling Earth, you'll have to perform solar system level engineering. Take the most impressive builds humanity's ever pulled off, from pyramids to Hadron colliders, space stations, and magnify them exponentially. To make a hell planet like Venus habitable, we're talking about pushing the planet into a different orbit. creating magnetospheres, changing the atmosphere, steering comets into the planet to create water sources. Yeah, I didn't say it would be easy. Okay, once you've managed to terraform the inner planets, well, you'll move on to the outer planets of the solar system, or start building colossal megastructures that encircle the sun. Yeah, humanity will build a Dyson sphere, a habitable mega spacecraft that harnesses most of the power of the entire solar system, which means that sometime between the year 3000 and 5000, humanity will upgrade to a Kardashev level 2. You're now part of a civilization capable of capturing the power of the sun. At this point, humanity has spread further afield than just the solar system. Now you'll move into interstellar space to explore deep within our Milky Way galaxy. Now I say humanity, but let's be realistic. Pushing our bodies to survive in space means we'll need to be able to bioengineer our frail earthbound bodies to withstand space radiation. With the help of nanotechnology and AI, your body, just like civilization, will get a serious upgrade. Homo sapiens, which haven't evolved much genetically, will be changing their bodies at will, interfacing with technology, and maybe even becoming more machine than human. All this travel in low-gravity environments will make you taller, and your eyes will evolve to be bigger. My eyes bigger, or you might not exist anymore. Yeah, that's the thing about civilizations. They tend to doom themselves the further they advance. Maybe it's the unchecked tech, or power struggles, or AI, or climate collapse, or American politics. Whatever it is, the idea is that the smarter a species gets, the more dangerous the tools it builds. And eventually it builds one that it can't control. The idea is called the Great Filter, and it might explain why we haven't seen any advanced aliens out there. Some scientists argue that in 10,000 years there's a 95% chance humanity will be no more. If I had to guess, well, if we accidentally terminate ourselves with homicidal AI robots, but if you didn't survive past that mark, well, you wouldn't see the way the Earth dies. So let's keep you alive a little longer. Okay, at this point, Earth will start to resemble pre-terraformed Mars. And no, it wouldn't be a hot world. Rather, it would be a frozen one because in 100,000 years, if global warming hasn't torched the planet entirely, Earth will plummet into a new ice age. Yeah, instead of rising heat, you'll be looking at rising glaciers. If we haven't built a proper Dyson sphere that can act as a planetary furnace, things are going to get very chilly. And then boom! The violent eruption of the Yellowstone volcano. Ash and pumice will jettison into the atmosphere, block the sunlight, and make Earth even cooler than Ice Age cold. If humanity hasn't been wiped out by now, we will successfully transition into a multi-planetary space-going species entering a new era of Homo sapiens. Okay, you worked really hard and finally human civilization became a Type 3 on the card scale. Now we harness and use all the energy created in an entire galaxy. Billions of stars, black holes, and interstellar winds now feed our unimaginable power grid. Dyson spheres encase stars like glowing pearls. It's a new era. And not just for you, but for the entire Milky Way. And even though you've harnessed the power of the entire galaxy, you still might not survive the dangers of the universe. Now, on a cosmic level, we're way too close to interstellar time bombs. Like the white dwarf in the T Pyxidus system, T Pyxidus is located over 3,000 light-years from Earth. It's an odd binary star system that keeps going supernova. The white dwarf in the system seems to be building mass, putting on the beef. And if it continues to do so, watch out because even though it's thousands of light-years away, it's still close enough to cause our planet damage. Supernovas or even hypernovas are violent and majestic events. They're the end of stars' lives, but they're responsible for producing most of the heavy elements in the universe, like iron, the iron in your blood. But in roughly 10 million years, this one could explode with a ferocity that ripples across the universe. The gamma radiation alone, stronger than 1,000 solar flares, could decimate Earth's ozone layer. If you're still wandering around at this point, you'll need to solve some kind of supernova defense, or that could be the end of life on Earth as we know it. At this point, humanity wouldn't be anything like what you know it to be. It'll be evolved in the same way that imagining the lives of our ape-like ancestors 10 million years ago is an almost impenetrable gulf, despite our shared unbroken genetic chain. That's a time before Lucy, the Oralopithecus. It's pre-human. And this is well past human. It's post-human. We could just be machines or machine-human hybrids or something entirely different. Okay. In 50 million years, Mars will tug one of its moons, Phobos, way too close. When Phobos reaches the Rho limit, that's the point beyond which Phobos's gravity wouldn't be able to hold it together. This moon will crumble and form a faint ring around Mars. On Earth, the continents of Africa and Europe will smash into each other, creating a rift of mountains high enough to rival the Himalayas. And this continental shift and the rise of new mountains will be violent for Earth, but the dangers can also come from the sky. 100 million years from now, an asteroid will hit the Earth. And not just any asteroid, the dinosaur-killing kind, but in this case, the human-killing kind. We better learn how to deflect large asteroids by then, because if we don't, it'll be game over for life on Earth. I wonder if dinosaurs ever had that thought. Earth's tectonic plates keep on drifting. At this point, they'll pull a reverse Pangaea and ram into each other, forming a new supercontinent, Pangaea Proxima. Every continent, with the potential exception of Antarctica, will eventually collide and create a giant landmass surrounded by a planet-wide ocean. Supercontinents are places of extremes. Extreme temperatures, extreme flooding, extreme drought, extreme mass extinctions, mega monsoons, and hyper-hurricanes. And, if we're still around and still keeping an eye on things, this will also be the time when you can watch Saturn go strangely ring-free. Its bright, iconic rings will eventually get pulled into the gas giant. Within 500 million years, you'll witness even bigger supernova threats like WR-104 out in the Sagittarius constellation 8,000 light-years away. Once it goes supernova, the gamma radiation will pulverize our ozone layer, causing extreme acid rain and set off another extinction-level event. In 1 billion years, well, things will get dark. No, not visually dark. Visually, it'll be quite the opposite. The sun will start emitting more energy than ever, and that will make Earth's temperature go way up. All that excess solar energy will interrupt the carbon cycle, kill photosynthesis, and cause oxygen levels in the atmosphere to drop. No plants, more problems. If anything were still alive on Earth at this point, well, it won't be for long. Most oxygen-breathing life on the planet will have died out. Only anaerobic creatures will survive for a while. Those are organisms that live and grow in environments without oxygen. As our planet is going through this atmospheric change, you'll have to leave Earth behind or move it to a different orbit if you still know how to do that old trick. In roughly 2.5 billion years, the changes get intergalactic. Our homey Milky Way galaxy will collide with the large Magellanic Cloud, a relatively small dwarf galaxy nearby, and what a show that'll be. Two galaxies smashing into each other. The sun will glow up, and not in a good way. Soon it'll reach its hottest point and grow 10% bigger than it is today. The outer edge of our solar system will see some major changes. One of the biggest moons in the solar system, Neptune's moon Triton, will drop under its Rho limit and get torn apart by the blue ice giant. And not long after that, celestially speaking, our Milky Way will collide with the nearby Andromeda Galaxy. Over 1 trillion stars will smash into the Milky Way. The two supermassive black holes at the centers of the galaxies will eventually merge and create a new, even more supermassive black hole. And Earth, well, at this point, it'll lose all its water. Okay, 5 billion years from now, the sun will begin entering its red giant phase. It'll start expanding toward Mercury, Venus, and Earth. Even if the sun doesn't fully consume Earth, things are going to get hot. Too hot for us or any other terrestrial life to handle. Of course, there will no longer be any life on Earth. It's possible that Mars that you terraformed way back in the year 2500 won't be consumed, but it's going to be far too hot to keep inhabiting. The habitable zone of planets in the solar system will really only include Saturn and Jupiter at this point, and since they're gas giants, well, they aren't super handy for humans. But it's possible you've terraformed their moons and you got a comfy spot on Ganymede or Titan or your own personal Dyson sphere. Either way, to survive in the universe in 5 billion years, humanity will need to have slipped the surly bonds of Earth and flown across the galaxies. Can we turn these alien worlds into habitable planets? Well, that's a story for another. What if